Hi dear students, today we are going to learn physics, and in physics I am going to teach you optics. Optics, physics class optics. And I hope after completing your board examinations you will be preparing for your competitive examinations. And due to COVID-19 many of you students will be preparing yourself at your residence, and teachers like us are supporting you to study well in that idea. So we are giving you some of the classes that is possible of us to make you understand the concepts better and recall it. I hope you are watching our channel Study HRS, and if you feel interested, keep watching and subscribe and share with your friends. Today I am going to teach you optics. Basically, optics deals with light. Everyone agrees with it, and it is a study of light. And you are making this study from your high school onwards. That is from 6th standard onwards. You are studying optics, and by this time you will be very much aware of what optics is. And now I am going to give you the gist and content what is given in your higher secondary level. In the higher secondary level, this optics is being classified into two different types. One is your ray optics, and another one is your wave optics. So these are the two different areas where your optics is being classified, and you are preparing on the same for your competitive examinations. First and foremost, I like to tell you something. What optics is? Optics is the study of the nature of the light. It is study of nature of light. Study of the nature of the lights. It's not only study of the nature of the lights, its production and propagation. So moreover it looks like theory, but you should have the idea behind optics, what you are going to learn. In ray optics, you are going to learn about reflection, refraction and dispersion. In wave optics, you are going to learn about diffraction, interference and polarization. Alright? So these pictures should come into your mind when you are learning optics. So these are the two different branches, and in our class and lectures today we are going to see ray optics followed by wave optics. And in optics, how I am considering the light as a ray, it's simply nothing but when you consider a torchlight, and if this torchlight glows, what happens? The light is being produced from this torch, and the form of light which is produced is the beams. You call these beams as rays. These beams are called as rays, and these rays are diversified, they are divergent. And whereas in wave optics, when you study the nature of the light, you study the same light in form of waves. You are studying this light in the form of waves. The study of light in the form of waves, you call it as wave optics, and the study of light in the form of rays, you call it as ray optics. See, every light will be in the divergent form, or it will be in convergent form, or it will be in parallel. For example, if you take a laser light, the light which is coming out of this laser, they are highly collimated and they travel in a straight. Here also the light travels in a straight line, but they are not diversified. They are parallel to each other and they are highly collimated. And why I am specifically saying this? And here in the laser light, the light which is coming out of it, again this is in the form of waves, and they are also highly collimated, which they travel for a longer distance. The only difference that I can say you as of now in the wave optics is, so in polarization, the light which is coming out of this torchlight, they are not in phase. But the light which is coming out of this laser light, they are in phase to each other. Which means if the waves which are in phase, you call them as coherent. If they are not in phase, they are called that the waves are incoherent. So this is a basic fundamental enough that you classify ray optics and wave optics. By having this beam of rays that you call them, which is coming out of the light, you are going to study reflection, refraction and dispersion. So again in wave optics, you know that light is considered as an electromagnetic wave. Light is considered as an electromagnetic wave. Why? Because the propagation of the light which it passes, it has both the electric field and the magnetic field. This electric field and the magnetic field, they are perpendicular to each other. They are perpendicular to each other and they travel sinusoidally along a straight line path. So with respect to this x-axis, they travel in a straight line and the electric field and the magnetic field are perpendicular to each other. So this is a basic general idea each and every student should have when they are preparing for the optics. Alright, so if you know this classification, then it is easy for you to get into the topic. And what are you going to study about ray optics? In ray optics, you are going to study about how this light is getting reflected in mirrors and how it is going to get reflected in lenses and how the light is going to get through prisms. So after that, we will study this interference, polarization, diffraction. Interference is nothing but when two waves coming out of a slit, when they coincide and they form interferences, right? Today again to continue with, we will go for studying about ray optics. To study ray optics, I should know earlier how the rays are passed through a plane surface. The plane surface, let us consider here one by one. So let us consider a glass surface. This is a glass surface which is plane, which is polished. If a ray is falling on this, any plane surface will make the ray to get reflected. This is called your incident ray, and the ray which is reflected, you call it as a reflected ray. And the point of incidence of this reflected ray, you call it as the normal. This point you call it as normal. The angle between the incident and the reflected ray, you call it as angle of incidence. The angle between the incident and the normal, you call it as angle of incidence, I, and the angle between the reflected ray and the normal, you call it as angle of reflection. So from this, you can form a formula. You can say the angle of incidence I, it is equal to angle of reflection, which is your first law of reflection. First law of reflection, very basic fundamental of all concepts that you are going to learn. The second thing is, we can easily say the incident ray, the reflected ray, and the normal all lie on the same plane, lie on the same point in the glass plane. So this is your laws of reflection. If you know the laws of reflection, then it is easy for you to go through the next topics. To continue with, to learn more about these laws of reflection, let us consider what will happen when a light ray is being passed from one medium to another medium. So if you take a glass surface, when you pass a light through it, for example, I am considering a glass surface. So this is my glass surface and an incident ray is falling on this. So let us take this point, and this is the normal. This is my incident ray. This incident ray, what will happen according to the law of reflection? Incident ray falling on a glass surface, it will get reflected. This is my angle of incidence and this is my angle of reflections. So because of a medium, what it happens? Some of the light, it is partially reflected, and some of the other light rays, it gets refracted. So there is a change in the direction. I think this is another medium. So I will stop it here, right? So this is my refracted ray. So what I can say out of my incident ray falling on a glass surface when there is separation of medium 1 and medium 2. Medium 1 is my air medium and this is my glass medium, which I can say this is medium 2. So whenever light travels from one medium to another medium, there is a change in the direction of the path. See here, so it is traveling like this. It's supposed to travel like this, but the light did not travel in this direction, but it gets deviated. So this angle we call it as angle of refraction. So some of the conditions that what is happening in plane surface when light is getting reflected when there is a medium difference. The point number 1 is that partially the light is getting reflected and some of the light is getting refracted into the medium, and third thing, there is an absorption of light and absorption of light in the medium. So this is an energy source. Light is a form of energy and some of the light is being absorbed in the medium itself. So whenever light passes, so these are the three processes happening, that is reflected, refracted and absorption of light. Now to study more into this ray optics, I am continuing with spherical mirrors. So spherical mirrors is also, so I think students are keep watching this, right? So you may think this is fundamental, but your examination point of view, the basic questions which appear in the questions which are appearing in the Neet are from the basic fundamentals, right? So now we will see spherical mirrors. Spherical mirrors. First of all, how these spherical mirrors are made up of? How these spherical mirrors are made up of? These spherical mirrors, for example, let us consider a hollow glass sphere, right? This is a hollow glass sphere. So this hollow glass sphere is cut by a plane. AB. So now the plane which is cut by a plane, the portion of the plane, the portion of the hollow glass sphere taken, you call this one as spherical mirror. You call this one as spherical mirror. If so, to make it a mirror, one of the surfaces is silverly polished. If the outer surface of this hollow glass sphere is silverly polished, you call this mirror as concave mirror. Concave mirror. In case if the mirror which is polished in the inner surface, you call this mirror as convex mirror. Convex mirror. So these are the basic fundamentals. How these spherical mirrors? So spherical mirrors are of concave mirror and convex mirror, right? So these concave mirrors or convex mirrors are taken from a hollow glass sphere which is cut by a plane, this surface. And we have some other point to study with the same, and everybody know, so if it is a sphere, there is a center towards it, right? This center, if it is a center, if it is a sphere, there is a radius for it, and this plane is cut by at the point A and B, and I am taking one point which is on the center of the sphere, this point as point P. Right? I will explain you what actually this is. See here, I am taking this is my concave mirror. This is my concave mirror, right? So now if I am drawing a line like this, so this is the point P, which you call it as pole. This point is nothing but, so this surface, right? This concave mirror surface is made out of a circle. So this is my circle. This is made out of a circle. If this is the portion which is taken off, there is a center for it. This center, you call it as center of curvature. You call it as center of curvature, right? So this point is O, and the distance from this center of curvature C and this point A, you call it as CA is equal to R, which is your radius of curvature. Then this will become your radius of curvature. Radius of curvature. Okay, so the portion A, B, C, this portion subtended from here from the sphere, It's the angle of subtended. It's the angle subtended. You call it as, this is the angle subtended portion is what? A, B, C of the hollow glass sphere. So what are the things that you can take into consideration when you are taking a spherical mirror out of this spherical glass surface in the concave mirror? So you have a pole. Pole is nothing but the middle portion of the spherical mirror, the center point, and followed by there is a center of curvature. The distance from the center of curvature to the point A, you call it as the radius of curvature, right? So you can keep this in mind. Followed by that, what are the other things that you are going to study in this? The other important aspects of this is, alright, so now you have learned about pole. This is your center of curvature, and the line which is passing through the pole, right, and the center of curvature, you call this line as principal axis. You call this line as what? Principal axis, right? So any light ray which is passing a parallel to the principal axis will get reflected through the focus. You call this point as principal focus. You call this point as principal focus. So what are the points that you had learned as of now to recall, right? I am keeping it here, right? So spherical mirrors, right? Spherical mirrors. In spherical mirrors, you are learning about points like, one is pole, second is point P, center of curvature, C, radius of curvature, then principal axis, then principal focus, So these are the various aspects. So apart from that, what are the other things that we can learn from this diagram is, because these are the essential features that you should understand before getting into the topic. Alright. So if it is a concave, the ray which is passing parallel to the horizontal axis will pass through the focus. In the similar way, if it is an convex, so convex, it is the inner surface is polished, and here it will be your pole, and the center of curvature will be here, because this is a circle of this, right? And your focus will be at this point. If any ray passing parallel to the principal axis, it will get reflected, and but it should have passed through this area, and this is your ray which is parallel to the principal axis, and this will get reflected in this way, but it will pass through this. So what I can say here from these two diagrams is that any image formed in the concave mirror in front of between the center and the pole, you call this as the image formed as a real image, and the image formed through these convex mirrors, you call them as virtual image. So this is also drive home point that you have to remember the difference between what is a real image and the virtual image. Okay, I hope you are following what I am trying to tell you. And now there is a small difference, alright? Suppose if this ray is not parallel to the principal axis, what will happen? This ray is not parallel to the principal axis, what will happen? See, for example, so this is my concave mirror. So this is point P, this is focus, and this is my center of curvature. A light ray which is passing parallel will pass through focus. So again, if a light ray, it is making an angle with the principal axis, so it will get reflected in this, because the angle of incidence is equal to angle of reflection. That you have to keep in mind, right? So then where my image could be, suppose there is another light which is falling like this, and it will move here, right? And my image will be forming at this place, right? So any vertical plane, so here it will make focus. So any vertical plane passing through the focus along the horizontal axis, you call it as focal plane. You call it as focal plane. So any vertical plane that passes through the focus along the horizontal axis, you call it as focal plane. So now you have an idea of virtual image, you have an idea of a real image, so you have idea of focal plane. Only when you are thorough with these terms, you can study this array optics in a easier manner. Now I am moving to the next concept. So the purpose of these mirrors are to form images. The purpose of these mirrors are to form images. So if an object is placed, right, how the images could be formed in the spherical mirrors? How the image could be formed in the spherical mirrors? To start with, so there is an condition that you should study. So what are the conditions that you are going to study? You call that as new Cartesian sign conventions. New Cartesian sign conventions. Right? What are these new Cartesian sign conventions? For example, see, this is one of the essential breakthrough that you should keep in mind when you are going to solve sums. This is a rule, right? Cartesian rule for any spherical mirrors. So if it is a spherical mirror, right, this is point P, this is center of curvature, and this is your focus, right? So let us consider an object is kept at this place. Let us consider an object is kept at this place. This is your object AB, and image is formed somewhere here. This is your A prime, B prime. First of all, what are the things that you should understand? The distance between the object and the pole. Distance between the object and the pole, you call it as object distance U. Object distance U, right? The distance between the image and the pole, you call it as image distance. You call it as image distance. The distance between the point and the focus, you call this as focal length. The distance between the pole and the center of curvature, you call it as radius of curvature. Right? Okay. Now I want to make measurement where in this concave mirror, right? Just I am erasing it for your convenience. I hope you have remember all these points, right? Now there are other new terms that you should remember. The term is object distance U. The condition, Cartesian condition number 1, it says any measurement you take in spherical mirrors, it should be always taken from the pole. It should be always taken from the pole. Number 1 point, distance should be always measured from pole. Number second point, the distance, if you measure along the incident ray, if you measure the distance along the incident ray, then take the distance in positive. If you measure the distance that is against the incident ray, if it is along the incident ray, it is positive. If you measure the distance against the incident ray, then it is negative. So let us keep these two simple points in our mind, and we can find how to find the distance, object distance and image distance. Let us see now. So this is along our incident ray, it is positive. This is against the incident ray, which is negative when compared with this object. So I am going to measure my object distance. Object is kept here. I have to measure my distance from this pole to this object. So from the pole to the object, I am measuring in the reverse direction, which is against the incident ray. So then my object distance will be minus U. Again, to measure my image distance, it is also measured from pole to the image. Image is formed here, and it is against the incident ray, my image distance will be minus v. And what about my focal length? It is minus f. And what about my radius of curvature? It is minus r. Right? So this is the way that you have to make measurement for a concave spherical mirror. Right? How to measure the distance in examination point of view. The sign conventions are very important. Right? Next, I will explain you for convex mirror. Right? So for convex mirror, you know, as I said earlier, if it is a convex mirror, right? Convex mirror, an object is kept here from infinity to any point between the pole, right? Your focus is here, the center of curvature is here, right? So the object is here, the light is incident on the surface, right? But you are going to make measurements where from point pole towards what? Focus or center of curvature. Then you can say the readings which you are going to take, whether it is an object distance or it is an what do you call image distance. Suppose it is an object distance, object is located here, from pole to the object which is against incident light, it will be minus u, whereas the image distance, if the image is here, you have to measure the distance from the pole to the image, then it will be positive v. Right? If there are conditions are not given, so simply for without any parameter there are values, then you no need to bother about the sign conventions. So sign conventions plays a very important role in solving the sums. So basic fundamentals I get taken for you. Then to go further relating to our mirror formula, before that I should know what is the relation between the focal length and the radius of curvature. I have to understand the relation between the focal length and radius of curvature. Focal length and radius of curvature. It is very simple, right? So you can say, right? Let us consider. So this is what? This is a concave mirror. So this is a concave mirror, right? This is point P, this is my focus, and this is my center of curvature. You know the simple law, right? Any ray which is passing parallel to the principal axis will always pass through the focus, right? And also there is another one point, for example, see here. So this is the point where the incident light is falling. The distance from the incident light to the center of curvature, you call this one as normal. Then if this is a normal, your angle of incidence will be equal to angle of reflection. I am considering this incident ray as A and B, right? So I am considering this angle formed in this triangle BFC is alpha. From my laws of reflection, I can say the angle of incidence is equal to angle of reflection. From the triangle, right, triangle BFC, I can say the angle R is equal to angle alpha. And similarly, the alternate angles I is equal to angle alpha. Having these conditions in mind, if I consider this triangle BFC, I can say this CF is equal to FB. In a triangle, since the two angles are equal and these two sides CF is equal to FB. And similarly, I can also say this point PF is equal to FB. But for my condition, I have this CP. CP is nothing but CP. The length CP is what? It is CF plus FP. What is CF plus FP? So CF is nothing but, right, CF plus FP. What I can do is that this FB and FB, since these both are equal, I can say CF is equal to PF, which means this CF is equal to PF. If this is the case, I can write CP equal to FP plus FP. So what is this FP plus FP? It gives 2FP. This is CP. So if you see perfectly, what is this? So CP is nothing but, what is C and P? You had learned earlier. CP is what? Your radius of curvature R. So radius of curvature R, what is Fp? Fp is your focal length. So it is 2f. So what I can say, the radius of curvature R is equal to 2f and my focal length f is equal to R by 2. The very valid relation, simple relation that you should learn, right? Okay, so this is the relation between the focal length and radius of curvature. So why I am taking this simple step to explain you is that, so you can play your mathematics over here to prove that how much is the length between the CF and FP, because since it follows the angle of reflection is equal to angle of incidence from the laws of reflection, then if you consider a triangle and if these two angles are equal, then these two sides should be equal. Let us take for this example, this side is approximately equal to this side because of this length. So equating this, I can say this R is equal to 2f, which means the radius of curvature is equal to 2 times its focal length, and focal length is nothing but half of its radius of curvature. So let us watch the lessons after a small break, right? Okay, keep watching.